Alright, I want you to turn on the page, first page, table of content. I want you to write down today's date, October 2nd. And I want you to write it down, algebraic properties of equality, tips for proofs on topic, and the page number is 7. So everybody should have this yellow copy, and then we're going to fold it half. We're going to paste this foldable on page 7. So I want you to fold it half. And I want you to turn on page 7. So I know we did page 6, and I want you to turn on page 7. I want you to write down page number, that's 7, on the right, and on the left as well. Okay? And then I want to go back to our foldable. I want to make a type. I'm going to just hold this interactive notebook on the side. When you're looking at the foldable, I want to write a title, which is Tips for Proofs and Algebraic Properties of equality. So that is a title for this photo. Okay, if you got it, and I want you to turn this paper side. So what you're looking at on the left hand side first. When we prove in algebraically or geometrically, we always start by stating given information, not prove the proofs without given information. We need to draw and or label a diagram. We don't have to do algebraic proofs, but we need to do in geometry proofs in order to understand better. It helps you or visualize problem. Second is look for connections between and what you are trying to do. So you have to look at the given, what we have given to, and how we prove it. We have to link together little information to form logic of the statements. So statement must be in certain order with a valid reason. Let's write down valid reason. Valid reason means either giving a definition, postulate, property of theorems. I know just gonna talking about properties for algebra, but in geometry proofs next 2 days we need to using definition, postulates, and theorems. Step 5, you can write it valid for the statements, then you cannot use the statements. Remember, there are multiple ways to get the conclusion. Ways, not only one direction, there are many directions. Usually students made a mistakes, and the last statement or last reason are not allowed to use prove or proven as a reason. You cannot say prove or proven at the last reasons. Sometimes there is a words in the given informations, vocabulary word given information, that word will be shown as a definition in your reason column. So this is a clue. Whenever you see the vocabulary word in the given information, the next reason, the second reason, will be definition of that vocabulary. But we're gonna move on to the algebraic properties. I'm sure you've been seeing those properties. Addition, subtraction, multiplication, division, substitution, distribute properties. These are not we just have a fancy word as we proving algebraic proofs. What it does is we have a description on the corner, and I'm going to give you examples at the middle. Addition property is you add same numbers or same thing on both sides. Not just that, you have to be add on both sides. That's why we call it equality. Equal means adding, subtracting, multiplying in same amount or quantity on both sides. So here's the example. If 10x minus 2 is equal to 8, what operation you need to isolate it x? Well, you have to add 2 on both sides. If you add 2 on both sides, call it addition property. Then I can cancel out minus 2. 10x is equal to 10. That subtraction property, subtract same number on both sides. If 13x plus 20 equal to 30, in order to cancel out plus 20, we have two opposite operations. Subtract 20, then 13x is equal to 10. So whatever you do on operations, write it down, operations as multiplication of a property of equality. Gonna underline it. Same thing. Multiply same numbers on both sides. If x over 3 is equal to 6, well, it's a fraction over 3. In our understanding, we know over 3 is divided by 3. The opposite operation of divided by 3 is times 3 on both sides. That's why we call it multiplication. Then we can simplify those 3's cancel out, so x is equal to 18. Division properties. You divide both sides by same number, add zeros. We don't divide it by 0, define solution. If 2x is 10, then how to cancel out 2? We need to divide it by 2. So x is equal to 5. Substitution property. In other words, for substitution, place or plug it in. So in the equation, substitute, or we have to plug it in with the different values, then we call it substitutes. So here's an example. If 5x plus 7y is equal to 12 and x is equal to 2, what I'm going to do is I'm going to substitute 2 into x. So then 5 times 2 plus y is equal to 12. So what I did was I simply plugged in x value into 2. Distribute properties. I know we usually, a lot of times we do the distribute properties parentheses. There is an example. If 3 times x minus 6 is equal to 21, what we're going to do is we're going to times 3 by each terms inside the parentheses. So then 3x minus 9 is equal to 20. We just remove the parentheses. I'm sure some of you about reflexive, symmetric, transitive properties before, but I'm sure a lot of you have not heard about these properties. This is new, these. And I'm going to even put those stars because we're going to using these properties a lot of times in geometry. So reflexive, when you're using this, really means reflect. It's coming from reflect. When you look at the mirror yourself, same thing. Things are always equal to themselves. So for instance, if x, then x is equal to x. If 5, then 5 is equal to 5. So it's a reflecting, it's equal to each other. Symmetric property means you flip sides of the equations. For example, if is equal to x is the same as x equal 5. So we just flip this 5 and x. This is called symmetric. Now, if we apply to the segments, if AB is equal to CD, we using symmetric, then I can flip these two. Then is equal to Alrighty, transitive. It's things that are equal to the same thing are equal to each other, which means if A is equal to B and B is equal to C, then we can conclude it A is equal to C. So it's actually transitive. A is equal to B, then we transit to C, then we conclude it A is equal to B. So substitution properties and transitives are very similar, but substitutes only apply for linear equations, and transitive is applied for or angle measurements or geometry proofs. Simplify. Next term is a simplify. We don't really change anything with the opposite operations. It just simplify what you already have. In other words, we call it, this is combine like terms. So for instance, if 2x plus 3 minus x equal to 4, I know in the statements we don't really do operations on both sides. We simply combine these terms. I know the like terms are 2x and minus x, so I'm going to combine these two terms. That is equal to x plus 3 is equal to 4. So on page 7, so open up in that interactive notebook. I label as a 7 on the left, 7 on the right. So on the left hand side, I want to paste this tips for the proofs properties on the left hand side, so I can show you the couple of examples on the right hand side. So I want to paste this with the glue or tape if you want to using it on the tape. So I'm going to open it. I'm going to tape and taped and taped. So we have foldable on the left and on the right hand side. You can open up your foldable and I'm going to follow along with the questions. So here is the examples. So here is example 1. Problem. So I'm going to say when information is negative 8 x minus 3 to negative 32, then we need to prove x equals 7. They already give you the answer. What you have to prove in algebraic proofs, you have to show your steps on the statements and give the reasons using properties. So first columns, then I want to write it down statements, and at the middle I want to draw the line. I don't know how many lines we're gonna take, so I want to have like enough lines, maybe 5 steps, and the second column should be the reason. So, and I'm gonna a T-chart. We can call it T-chart as well. So I'm gonna draw the line. You can use her in the basket. So there is a reason. So our first statement should be the given information. Remember, we always start with given information. Our given information is the original problem. So negative a parentheses x minus 3 is equal to negative 32. So that is our given information. That's our first step. And the reason is it says a given. So I'm going to using given as a reason. Second step, we gotta solve it. We're gonna get through the steps. If with the parentheses, we are going to do distribute properties. So I'm gonna write down negative a x, negative a times negative 3, negative change to positive, so plus 24, that is equal to negative 30. Remember, we just did attribute, then reason is distributive properties. Then third step, the parentheses. So erase the parentheses. Is we need to subtract 24 on both sides. So we subtract 24, subtract 24. It's a negative 8x is equal to negative 56. So what I did here is, so I can say subtraction property of equality. And the last step is we need to divide by negative 8 on both sides. And you divide by negative on both sides. It's a negative, no, it's a positive 7. Negative, negative, change to positive. So we can call it its division property of equality. Okay? Let's do the second question, second example. Maybe we can use some fractions so you understand what we need to do. Example 2. So we say given information is negative 1 is over x over negative plus 10. And then proof, we need to prove that x is equal to 33. How do we do that? Let's make a T-chart with the statements and the reason. And then I'm gonna draw the line, maybe 4 or 5 spaces, and draw the T-chart. So first step to be always start with given information, negative 3 plus 10. That is a given. The first step I need to do is we need to get rid of 10, which means we have to add 10 on both sides. Add 10. So I'm gonna write it down, addition property of equality. So second step is, I know negative 1 10 is 9 is equal to x over negative 3. Well, cancel out negative 3. We need to multiply negative 3 on both sides. So we can say it's multiplication property of equality. So 3 times 9 is 27 is equal to x because they are cancels out. Did I do something wrong? Let me see. Whoops. I know in here we have to subtract it. Well, I'm going to change it to subtraction. So it's addition, it should be subtraction. So now I know negative 1 minus 10 is 9. It should be minus 11. So I'm going to just cross them out. So everything is completely wrong. It's messy. Just cross them out. I'm going to write it down again.